Okay, so in this video we are going to solve this question on proving irrational numbers. So the question reads, prove that 1 over 2 root of 2 minus 1 is irrational given that the root of 2 is irrational. Okay, so we prove this question by what? Contradiction. So we are going to assume the opposite of what we want to prove. Okay, so we're going to say assume 1 over 2 root of 2 minus 1 is rational. Okay, then there exists, okay, so there okay, so then there exists two integers a and b such that b is not equal to 0 and a over b, okay, is in its lowest terms. So what does it mean it's in its lowest term? It simply means that this a and this b do not have a what? A common factor. We do not have a number that can divide this a and this b. Okay, so this here should always be your what? Your first assumption that you write as you are trying to prove this. Okay, so always make this assumption. So write this, okay, all of it the way you have written it, and then once you write it, and then you go on with your proof. Okay, so I'm going to erase this. I'm going to erase this, and then from our assumption, okay, we can now say that, okay, from our assumption we can say that 1 over 2 root of 2 minus 1 is equals to what? A over b, since we're assuming that it's rational. Okay, it's rational. Okay, so from this, what are we going to do? Okay, so from here we're just trying to make this root of 2 to be the subject of a formula. Okay, immediately we make the root of 2 to be the subject of this formula, or to be on its own on the left hand side, okay, then it means we have our contradiction. So what are we going to do? We're going to say 1 over 2 root of 2, and then on the other side we have a over b plus 1. Okay, we have a over b plus 1, so we still have 1 over 2 root of 2 is equals to, so let's add this. So b is the common denominator, so there we have a plus 1 into b, it's b, so we have a plus b. Okay, and then from here, how can we make that root of 2 to be the common, to be the subject of the formula here, or to be on its own on the left? We're just going to cross multiply. So this here, we are going to cross multiply with this guy. So what we end up getting is 2 root of 2, and then in the brackets we have a plus what? B. This is equals to what? B. And then from here we can divide both sides by 2, a plus b. Even this side we divide by 2, a plus b. Okay, so what we get now is root of 2 on its own on the left, okay, because this and that will cancel, is equals to b over 2a plus what? 2b. So this, what I've written here, is what we want. Okay, as long as you have something like this, okay, where you have the root of 2, okay, on its own, then we can get our contradiction. Okay, so remember from the question we are told that this root of 2 is irrational. Okay, and then what I have on the right hand side here is an integer b, okay, being divided by the sum of an integer a and an integer b there. Okay, so if I divide an integer over an integer, I'm going to get an integer. So an integer is a rational number. Okay, an integer is a rational number. So what we have is that on the right we have a rational number, and then on the left we have an irrational number. So that's a contradiction. Okay, it is contradicting itself. So what you are going to say is this to finish up the proof. Okay, so you are going to say that, okay, you are going to say that my right hand side, or I mean my left hand side, is equals to root of 2, which is irrational, while my right hand side is equals to b over 2a plus 2b, and this is rational. Okay, so a rational number can never be equals to an irrational number. Okay, so we have that the left hand side is not equal to what? The right hand side. So this here is a contradiction. So we are going to say hence by contradiction, okay, hence by contradiction 1 over 2 root of 2 minus 1 is irrational. Okay, so that's how we solve this question. Right, so that's it for this video. Please like, share, and subscribe to my channel for more videos. Okay, so I'll see you in the next video.